Conversions between fractions and decimals. Fractions form a group that mathematicians call the rational numbers. Rational because they are ratios. We write a fraction, a rational number, as a decimal. One of two things happens. It either terminates or repeats. Well, those are fancy words. What does that mean? Fractions that form terminating decimals. And of course, terminating simply means coming to an end. So very simply, if we write 1/4 as a decimal, it's 0.25. After two places, the decimal just comes to an end. There's no more decimal after that. There are just two decimal places. That's it. That's a terminating decimal. Another example, 3/8. That's 0.375. So that's also a terminating decimal. It's a decimal that just comes to an end. That's not an approximation. That's the whole thing right there. So these are terminating decimals. If it doesn't terminate, if it goes on forever, then it repeats. Fractions that form repeating decimals. So for example, with 1/3, that's just 0.333 repeating. So it's the same digit repeating over and over again. Technically, to write it correctly, we'd have to write an infinite number of threes. That would be inconvenient. Instead, we write it with a bar over the last three, and that bar just means continue to repeat this decimal forever. Similarly, 1/7. This is not a single digit repeating. This is a set of digits repeating. 142857, 142857, 142857. That whole pattern repeats like mathematical wallpaper forever. And the way we indicate that is by writing the long bar over that entire set of repeating digits. So, once again, fractions, when written as decimals, they either are terminating decimals, decimals that come to an end, or they are repeating decimals, decimals that repeat a particular pattern. There are a few fraction to decimal conversions you should have memorized for efficiency on the test. Many of these are probably already familiar. Basically, you should be familiar with the decimal form of almost every fraction with a single-digit denominator. Now, the really easy ones, 1/2 is 0.5, 1/4 is 0.25, 3/4 is 0.75. You may have these memorized already. If you don't have these memorized, please memorize these. These show up everywhere on the test. These are very important. Another very popular one, 1/3, is 0.3333 repeating. We've met this already. If we multiply this by 2, we get 2/3 is 0.666 repeating, and of course if we round that off, the last 6 becomes a 7. 1/5 is 0.2. Suppose I just multiply both sides by 2, then I would get 2/5 is 0.4. Or I could multiply both sides by 3, I would get 3/5 is 0.6, or multiply by 4, and I get 4/5 is 0.8. Very important to realize that these are just multiples of one another. 1/6 is 1.666 repeating. And of course, if we round that off, we get a final 7. Now, we don't have to worry about 2/6 because 2/6 is 1/3, 3/6 is 1/2, 4/6 is 2/3, but the one that does actually show up as a new decimal, 5/6, is 0.8333 repeating. That's a good one to know. Now 1/7, I'm putting this in a slightly different color, 1/7, I'm going to say you probably don't need to memorize this 6-digit pattern repeating over and over again. If you want to memorize this 6-digit pattern, go ahead, be my guest, that's wonderful, but you don't need to have it memorized. I would say if you just memorize the first 3 digits, 0.143, so that's just rounded off to the 1,000th place. If you know that, that's an excellent approximation for 1/7, and that would tell you virtually everything that you would need to know about 1/7 on the test. 1/8 is 0.125, multiply both sides by 3. We get 3/8 is 0.375. Start out with 1/8, multiply both sides by 5. We get 5/8 is 0.625, multiply by 7. We get 7/8 is 0.875. Notice that I wasn't worried about even numerators, because if I have an even numerator over 8, it would cancel and it would be something else in the lowest term, something that we've already handled. 1/9, that's a bunch of ones repeating. Now this is particularly convenient because it means I could multiply by any digit and it would just be that digit repeating forever. So for example, if I multiply both sides by 7, 7/9 is a bunch of 7s repeating. Any digit repeating is that digit over 9. 1/10 is 0.1. 1/100th is 0.01. 1,000th is 0.001. These should be familiar already. But we can use these to get some other fractions. So for example, 1/20th, well, one way to think about that, I'm just going to multiply numerator and denominator by 5. And the reason I'm doing that is because I want to get 100 in the denominator, 5 over 100, which of course is 0.05. That's one way to think about the decimal form of 1/20th. Another way to think about fractions with denominators that are multiples of 10. So 1/20th, I could write that as 1/2 times 1/10. Well, 1/2, I can write that as a decimal. That's 0.5. And 1/10, of course, is 10 to the negative 1. Well, if I multiply these, multiplying by 10 to the negative 1, as we found 2 videos ago, this slides the decimal place over one place to the left, and I get 0.05. Again, 1/40th, well, this is 0.25 times 10 to the negative 1. Again, slide the decimal place over one place to the left, I get 0.025, and that's the decimal for 1/40th. 1/600th. Well, of course, this is 1/6 times 100th. The 1/6 I know is a decimal, and 100th is 10 to the negative 2. That means slide the decimal place 2 places to the left. And so then this is 0.001666 repeating. That is the decimal form of 1 over 600. With these tips in mind, you should be able to find the decimal equivalent of almost any fraction given on the test. Finally, I will make a few remarks that aren't directly tested, but may help to clear up any misconceptions. All the decimals in this lesson so far either terminated or repeated, but that's not true of all possible decimals. When fractions, aka rational numbers, are written as decimals, they always terminate or repeat. That part is true. The decimals that neither terminate nor repeat are called the irrational numbers, the numbers that can't possibly be written as a ratio. These numbers go on forever in a non-repeating pattern. Familiar examples include pi and square roots of numbers that aren't perfect squares. So for example, here are some famous irrational numbers. Of course, pi, the square root of 2, the famous mystical number, the golden ratio. All these go on forever, and there's no repeating pattern. None of these can be written as a fraction of integer over integer. In this lesson, we studied the common fraction to decimal equivalents and discussed how to generate more using powers of 10.